Hey class, Mr. Husted here. Today we are moving on to Chapter 2, Lesson 4, Postulates and Diagrams. We are knocking on the doorstep here of proofs, so make sure that we have a good understanding of what's going on, especially in this lesson and all the lessons before this. So before we start anything, let's take a look at a nice long list of postulates here. Okay, they don't have any real names other than postulates 5 through 11, and they're all about points, lines, and planes. Just to go through a couple of them, postulate 5, through any 2 points there exists exactly one line. Postulate 6, a line contains at least 2 points. 7 is if 2 lines intersect, then they intersect at exactly 1 point. You can read the rest of them there. These are all mostly common sense, but again, like we've talked about, nothing in geometry is common sense. We are now going to have to prove everything that we work through. Okay, so to start off, we are just simply going to look at a picture and tell which postulate is being illustrated in this diagram. So if we look at example 1a, we have 2 lines, and if 2 lines intersect, they intersect at exactly 1 point. So there should be a postulate up here that talks about 2 lines that intersect and how they intersect, and that would be postulate 7. If 2 lines intersect, then they intersect at exactly 1 point. So all we would have to say is this is postulate number 7. Please highlight, please circle, anything you want to do. Draw attention to this particular set of postulates, because we will be using these. You will need them today, you'll need them tomorrow, you'll need them the rest of this chapter. Okay, example 1b, we have 2 planes. They look like 2 pieces of paper, and when 2 planes intersect, then they intersect at a line. So if we look up through here, we need to look for something. We need to look for 2 planes and what happens when they intersect, and that would be right here at postulate number 11. If 2 planes intersect, then their intersection is a line. So we'll simply just say postulate number 11. So this is kind of getting you in the habit of looking for reasoning behind what happens in an if-then statement. Even though these are diagrams, they're still if-then statements. So look through your postulates there. Okay, so let's take a look at example 2. Use the diagram to write examples of postulates 9 and 10. Postulate 9 is a plane contains at least 3 non-collinear points. So we need to look for 3 non-collinear points that make up a plane. So if I'm looking here, I'm going to be looking at plane P. So that is going to be this sheet of paper looking thing here, and we're looking for 3 points that are not on the same line. So those points would be point A, point B, and point C. So postulate 9, there are 3 non-collinear points in a plane, point A, point B, and point C on that plane. Postulate number 10 says, if 2 points lie in a plane, then the line containing them lies in the plane. So in looking at our illustration down here, 2 points that lie in a plane, so we'll talk about point B and point A. If those 2 lie in the same plane, then line N, which is the line that contains both of them, I'll highlight it kind of here for you, also is in that plane. These all lie in plane P. So just kind of trying to give you a little breakdown more of what some of these postulates mean. You can't have 2 points in a plane and then their line not be in the same plane. Okay, again, common sense stuff, but we're just trying to put words and pictures to it. Okay, and flip over your paper. All right, taking a look at the concept summary here. If we're looking at a picture or a diagram, there are certain things you can assume, there are certain things you cannot assume. For the most part, the things that you can assume, they're pretty obvious here, okay? All points shown are coplanar. If they all look like they're in the same plane, they are in the same plane. You have straight lines, therefore you're having linear pair, vertical angles, all that good stuff. Some things to note here that you cannot assume is that G, F, and E in this particular picture are collinear. Even though it looks like it, they look very similar. They look like they might be on the same line, even they're all straight across there. We can't assume that. If there's not a line connecting all of them, we can't just go ahead and draw a line. Another one, BF, line BF and CE intersect. They do not intersect within this plane, therefore we could say that they are parallel, but we can't assume that they're going to intersect even if it looks like it at some point they will. Let's see what else. Angle BHA is congruent to angle CJA. There's lots of things about parallel and perpendicular lines that we can't assume unless something is marked. Okay? So just, again, something to highlight, something to put a big circle around, start, whatever you want, so that way when we need some information on diagrams, we can go back and look at this picture. Okay? All right, so take a look at example 3. We're going to sketch a diagram showing line TV intersecting line segment PQ at point H, and so that TW is congruent with WV. So let's do this first part here, where we are drawing a line and line segment intersecting. So TV, and we have PQ. So we have TV, PQ, and they intersect at point W. So that's the first half of it. The second half is we want to mark that TW is congruent to WV. So we have TW here, and we want to say that it is congruent to WV. So if you remember back to congruence and all that stuff, we use tick marks to show congruence. So you can use, let's use something that's actually going to show up. You can use 1, you can use 2. It doesn't matter whether you use 1 or 2, just make sure that you mark that both line segments are congruent. And that's how we sketch a diagram showing that line TV intersects PQ at point W and that those two line segments are congruent. So let's move on to the last example here. Due to some technical difficulties, this problem has already been filled out for you, but what we are doing here is we're looking for statements that cannot be assumed based upon the diagram that we are looking at. So if you're having trouble reading this, hopefully you can see it on your paper. The first one says that A, B, and F are collinear. If we look here, we see A and B are collinear, which means that that line is that the F would also be on that line, and it makes it collinear. So that's something that we can assume. That's why it's crossed out. It says next that E, B, and D are collinear. We cannot assume that, even though it looks like there's a straight line going through them. If there is no line showing that, then that's an assumption we can't make. Next one, line segment AB is perpendicular to plane S. We have AB. We have a perpendicular sign there, so it's showing that this is perpendicular to plane S. So again, something that we can assume, so not an answer to our question. It says that CD is perpendicular to plane T. There is no right angle marking there, so that is something we cannot assume. And lastly, line AF intersects BC at point B. So if we look at AF and BC, they do intersect at point B. So that's something, again, that doesn't answer our question. So just those two things we cannot assume when looking at this diagram. So lots of information today, lots of postulates, so make sure that you understand what each of them is talking about. Bring any questions with you to class, and we'll see you then.